Right now, across laboratories in the United States and China, engineers are building machines that will redefine what combat looks like. These are not remote-controlled drones. These are humanoid robots that run faster than soldiers, lift loads that would break a human back, and operate without rest for days. The Pentagon is paying attention, and so is Beijing. Today we are breaking down 5 humanoid robots that could deploy to war zones this year. Number 5. Foundation Phantom Mark 1. Most people outside robotics circles have never heard of Foundation Robotics. That needs to change. The Foundation Phantom Mark 1 was not built for trade show demonstrations. It was built for the real world. And in robotics, those are two very different goals. Most humanoid robots are developed in controlled environments. They perform well on smooth floors and predictable surfaces. Then they struggle when conditions become difficult. Foundation Robotics took the opposite approach. The Phantom Mark 1 was designed to operate in rough terrain from the beginning: gravel, rubble, mud, steep slopes, and narrow corridors. These are the environments where soldiers actually work. These are the environments the Phantom Mark 1 was engineered to handle. Its balance and shock absorption systems allow it to adjust to changing surfaces in real time. When the ground shifts underneath it, the robot compensates immediately. When it encounters stairs or uneven terrain, it keeps moving with a smooth and reliable gait. The Phantom Mark 1 can navigate debris fields, ramps, stairs, and tight indoor spaces. Those are exactly the places where traditional vehicles often cannot go. It can also carry heavy loads for long periods without fatigue, loss of performance, or the need for rest. Its arms provide enough flexibility to carry equipment, manipulate objects, and interact with its surroundings. In military operations, that matters enormously. Soldiers often carry massive amounts of gear across difficult terrain. By the time they reach their objective, exhaustion has already reduced their effectiveness. A machine that can carry that burden indefinitely represents a major advantage. Number 4. Boston Dynamics Atlas. Everyone talks about the backflips. They are impressive. But from a military perspective, the backflip is not the most important thing about Atlas. The real achievement is dynamic motion control. Atlas calculates movement in real time, adjusting its balance and body position as conditions change. That ability is essential in chaotic environments where nothing is predictable. Boston Dynamics has deep connections to military research. The company received significant support from DARPA, the agency responsible for developing advanced technologies for the United States military. Earlier robots like Big Dog were designed specifically for battlefield logistics. Atlas represents the next step in that evolution. The newest electric version of Atlas is quieter, more efficient, and more agile than previous models. It runs, jumps, climbs obstacles, and recovers from stumbles with remarkable precision. During testing, engineers have repeatedly pushed and shoved the robot to evaluate its balance. It consistently regains control and continues operating. Atlas also features advanced arms and hands capable of handling tools, carrying loads, and manipulating objects in complex environments. Its flexible torso allows it to work in confined spaces, reach overhead, and operate at ground level without losing stability. The truly remarkable part is that Atlas is not limited by the physical constraints of the human body. Its joints can generate forces and speeds beyond what people can safely achieve. It does not suffer muscle fatigue or injury. Boston Dynamics has publicly opposed weaponizing its robots, but capability and intention are different discussions. Atlas remains one of the most capable humanoid platforms ever created. It can operate in hazardous environments, recover from impacts, and continue functioning where humans might fail. Militaries around the world understand the significance of that technology. Number 3. Unitree H1. The statistic that grabs attention immediately is speed. The Unitree H1 has reached more than 3.3 meters per second. That makes it one of the fastest humanoid robots ever built. This is not a cautious walk. It is full dynamic running, with moments when both feet leave the ground, just like a human runner. In military operations, speed can be critical. The ability to cross exposed areas quickly, reposition rapidly, and move efficiently through dangerous environments creates a major advantage. The H1 stands roughly 1.8 meters tall and weighs about 47 kilograms. That relatively low weight reduces energy consumption while maintaining strength and mobility. Unitree achieved this through powerful electric motors and lightweight structural materials. The robot has also demonstrated strong durability. It has been tested in rough terrain, full recovery situations, and demanding movement scenarios. When it falls, it gets back up. When it encounters uneven ground, it adjusts. When pushed, it recovers its balance. What makes the H1 especially important is not a single feature. It is the combination of speed, durability, useful payload capacity, and lower cost. Military effectiveness is not only about having the most advanced machine, it is also about having enough machines to make a meaningful difference. Unitree's pricing makes large-scale deployment far more realistic than many competing platforms. Number 2. EngineAI T800. The EngineAI T800 did not receive its name by accident. Inspired by the Terminator, it is one of the most imposing humanoid robots to emerge from China's rapidly growing robotics industry. Where some robots impress with agility or speed, the T800 stands out through sheer physical presence and strength. It was designed for demanding real-world environments where equipment must continue operating despite impacts, heavy loads, and difficult conditions. The robot's large structural frame is built to absorb punishment and remain operational over long periods. Its joints emphasize endurance rather than short bursts of performance. That distinction is extremely important in military applications, where equipment faces constant stress and rough handling. One of the most valuable design features is field maintainability. Many advanced robots require specialized facilities and expert technicians for repairs. The T800 was designed so damaged components can be accessed and replaced in operational environments. That practical approach is what separates impressive technology from useful military equipment. Strength is where the T800 truly excels. Its arm systems are designed for heavy-duty tasks involving lifting, pushing, pulling, and carrying. Ammunition, evacuation equipment, engineering tools, and large sensor systems can all be handled without the physical limitations faced by human operators. The result is a platform built not only for performance, but for sustained operation under demanding conditions. And here we are at number 1, the Figure 03 from EngineAI. This robot is not number 1 because it is the strongest or the fastest. It is number 1 because it combines advanced hardware with powerful artificial intelligence. Through its partnership with OpenAI, EngineAI has integrated large language model technology directly into the robot, allowing people to communicate with it using normal conversation. The Figure 03 can understand instructions, identify objects, plan actions, and complete multi-step tasks. When unexpected situations arise, it can adapt instead of waiting for constant human guidance. That moves it much closer to genuine autonomy than previous generations of humanoid robots. Standing at human height, the robot can operate in spaces already designed for people, including buildings, vehicles, and workplaces. That makes real-world deployment far more practical. Most robots still require continuous supervision. Figure 03 is moving toward a future where it can receive a mission objective and determine how to accomplish it on its own. In military terms, that changes everything. Figure 03 earns the top spot because it does not just represent today's most advanced humanoid robot, it represents where military robotics is heading next, and that future is arriving faster than many expected.